My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 159. In this lecture, we will try to understand another set of problems in which samples are dependent. That is, I can say these samples are dependent samples. Test means of two related populations, that is paired samples. There is another name for this paired samples, that is I can say paired or matched samples, I can say, isn't it? Repeated measures before and after same population. We are collecting the data before and after. For example, the blood pressure of same people before and after a dose. The two samples are dependent because they are taken from the same sample. Use difference between paired values, that is di equal to xi minus yi. What is this xi? What is this yi? I can say xi is before treatment. Before treatment. Yi is after treatment. That may be something like suppose a lot of hair oil company advertisements are coming. Before applying the hair oil, what was the length of the hair? After applying the hair oil, what is the length of the hair? That's something like before after. Even we discussed about blood pressure before dose and after dose. Assumption here is both populations are normally distributed. The test statistic for the mean difference is a t-value with n minus 1 degrees of freedom, t equal to small d bar minus capital D naught by sd by root n. What is my d bar? Sigma di by n, which is equal to x bar minus y bar. My capital D naught is hypothesized mean difference. SD is sample standard deviation of differences. N is the sample size. Here also we have three, I can say, see, the first one is left tail test. What is the reason? Depending on sign in alternative hypothesis. This is left tail test, this is right tail test, this one is two tailed test. Just see decision rules. Dependent sample decision rules. Reject h naught if t is less than minus of tn minus 1 comma alpha. Reject h naught. This is related to left tail test. This one is related to right tail test. If t is greater than tn minus 1 comma alpha, whereas for two tail test we know that will be your t is less than minus tn minus 1 comma alpha by 2, or t is greater than n minus 1 comma alpha by 2. It's not new thing which we discussed a lot on these concepts. My t is capital D, as I told you, same n minus 1 degrees of freedom. We will take an example for dependent samples and we will try to understand this dependent sample with simple example. Just see this example problem. An article in the Journal of Strain Analysis compares several methods for predicting the shear strength for steel plate girders. Data for two of these methods, Carlucci method and Lehigh procedures, isn't it? When applied to 9 specific girders, this is sample size is 9, that you must remember, this point is important, but the sample size 9 are shown in table. We wish to determine whether there is any difference between the two methods. There are two methods. First method is called Carlucci method and Lehigh method. We want to test whether there is any difference. What is my status quo? Status quo is there is no difference, isn't it? This is grider. This is first one is method 1 and this is method 1, Carlucci method and Lehigh method. I am calculating differences. Just observe all these. Look at the differences. or positive. There is a possibility of differences may be negative also. So for step 1, anyway these differences we calculated. So the first step number 1 is what you have to do. The parameters of interest is the difference in mean. Shear strength between two methods. I can say mu d. Mu d means difference between the means, that is mu1 minus mu2 equal to 0. Means there is no difference. Actually that comes under null hypothesis. What is my null hypothesis here? I can say, just let me write otherwise, my null hypothesis H naught is mu d equal to 0. What is my mu d? Mu1 minus mu2 equal to 0. And what is my alternative hypothesis H1? Alternative hypothesis H1 is mu d not equal to 0. Isn't it? The test statistic T naught, what is my test statistic T naught? Equal to d bar by SD by root n. This is my, it is not, if it is not paired sample, if it is, I can say like this, if it is not paired, if it is not paired sample, what is my formula? T equal to x bar minus mu by s by root n, if it is not paired sample. I can say here x bar is, what is my x bar? X bar is mean of the differences. It is a mean of the difference. Mean of the differences. Isn't it? This, what is my S? S is standard deviation of the differences. This one is standard deviation. Deviation of differences. Deviation of what? Standard deviation of differences. Isn't it? Differences. Yes, I can say all other same. N is the sample size. What am I saying? There is a relation. Just say, try to identify a relation between these two formulas. Every statistical test has some link, some relation. That's why you have to follow the order of learning. These statistics. If you follow the sequence, then you can connect all these statistics. When you look at the table alpha by 2, what is my assumption here? Alpha is 0.05, alpha by 2 means 0.025. What is my sample size? Sample size is n minus 1, 9 minus 1, 8. This is my tabulated value, 2.36 is stable value. Table value is 2.306. How can I get calculated value? D bar by SD by root n. Just if I calculate D bar by SD by root n, I will get 6.05. Anyway, I will calculate with the help of Python code. It's not a difficult thing. Here, the sample average and standard deviation of the difference we calculated. Just we are substituting. Even you can make use simple Python code to calculate it. Here conclusion is my t value is 6.05. How you got that 6.05? By applying that formula. Here my conclusion, your calculated value 6.05 is greater than 2. This one is stable value, isn't it? Stable value is greater than 2.306. We conclude that strength prediction method yields different results. Means you are rejecting null hypothesis. Even you can check p-value. P-value at the p-value for t naught is t naught equals 6.05 is 0.0002. This is less than your alpha, isn't it? If it is less than alpha, what I have to do? I can say like this: 6.05 is far away. We have to reject null hypothesis. Look at the p-value. This is my p-value. 0.0002 is my p-value, isn't it? Yes. Let me erase first. Yes. I can say 6.05 is far away. We have to reject null hypothesis. How can I do it? Otherwise, let me show in. Let me take one simple. If you plot this one on a t distribution curve, what happens? This is this is my t distribution curve. This left side one is minus 2.306. My right side one is plus 2.306. Your calculated t is 6.05, means it is right side of 2.306. That is critical region. This six, if it as it is in critical region, what is your conclusion? Your conclusion is reject null hypothesis. Reject null hypothesis means reject H naught, isn't it? With the help of p-value also, you can draw the conclusions. Here, what is your p-value? My p-value is 0.0002. Here, what is my alpha? Alpha is 0.05, isn't it? Here, p-value is less than alpha. Therefore, what is your conclusion? You must reject H naught, isn't it? You can make use p-value concept. Otherwise, you can calculate t value. Your calculated value 6.05 is exceeding your tabulated value 2.306. Therefore, it is in critical region. Either you can make use p value or t value. Both are end result is same. Just if you want to perform some test on Jupyter notebook, just this is the Carl method, this is Lehigh method. Just I am collecting data from given problem. Start t test REL. REL means relative. REL means what? REL means relative. What does it mean? What's a relative mean? That means dependent. Now we are calculating dependent samples, isn't it? That means dependent. What is your 6.08? It's 6.05 approximately, they are saying. This is 6.08 and this one is exceeding your p value. Anyway, I need not discuss again and again. This is my p value. We will go to Jupyter notebook and you can check it out whether it is correct or not. Just let me go to Jupyter notebook. Just see this one. This is Carl method. This is Lehigh method. I collected this data and just I am reading. Starts.t-test REL. I already explained what is REL. Relative. Relative means what? Dependent samples. For dependent samples, I am calculating this. This is 6.08. Isn't it? This 6.08, approximately 6.05 you were saying. This is my t value, this is my p value, isn't it? How can I calculate t value? For alpha by 2 means 0.025, n minus 1 degrees of freedom. Our sample size is 9. 9 minus 1 means 8 degrees of freedom. This is 2.306. As I told you, on left tail you have minus 2.306, on right tail plus 2.306. This 6.08 is exceeding this value. Therefore, I must reject null hypothesis. Even if you want, you can follow this p-value approach. This p-value is also less than alpha. Alpha is 0.05. Therefore, I can say I must reject H naught. Just this one is simple lecture. Just go through it. If you have any difficulty, please keep a comment. Thank you very much.